Hello and welcome back to Physical Science Online. Today we got a little demo for you using a Slinky. So this is a real life demo. You've seen Bill Nye use this. You've seen the book refer to this, but it's just something cool we normally do in class, making a recording of it for those of you that unfortunately aren't in school for whatever reason. So here we go, a little demo that we normally do in class. A spring or a slinky works pretty well for real life examples of waves. Basically, you can oscillate. So that's what our simulator will do today, where I actually just move my arm back and forth. And when I have particles moving back and forth, I have a transverse wave. Transverse wave has the peaks and crests, and they kind of look just like a curve. And then I can increase the wavelength by giving it more energy, moving it more side to side, so that makes it bigger wavelength. Or I can increase the frequency by going faster. See, so now in the same amount of time, I have a full wavelength going instead of a half of one. And maybe I can even go faster yet. I can get a wavelength and a half in. And then with these different frequencies, sorry, I'm trying to create standing waves because there we go. I can also give it more wavelength at the same frequency, or more amplitude at the same frequency. So same wavelength, same frequency, more amplitude, less amplitude. Same frequency, same wavelength, increasing frequency, and wavelength. That's just a real life example of a transverse wave. It's a little bit harder to see on this demo. It's kind of cooler even in person, but I can also do a longitudinal wave where I just move back and forth. It's a little bit harder to see. Remember, a longitudinal wave is when it's moving back and forth through the medium. So that would be an example of a longitudinal wave. And that one's same thing with a spring. So hopefully that was a cool little quick demo. You've seen that a couple times, but I like to just go through it again. On that longitudinal wave, the wavelength would be the distance between the compressions, and of course going faster or slower. I guess I'll demo those. Would help as well. So longitudinal wave faster, higher frequency, and you can have different wavelengths. Unfortunately, it kind of falls apart and becomes a transverse wave because of the closed end. But that's our demo. Thanks for watching. Enjoy your lab today with the Waves on a String simulator.